So in this, refrigerator works between 4 degree and 30 degrees centigrade. So therefore we have T2. So in refrigerator, you see the inside it is cool, outside the room temperature is hot. So room temperature is T1, which is 30 degrees centigrade. So 30 plus 273, which is 303 Kelvin. T2 is 4 plus 273, which is 277 Kelvin. Okay. Now it is required to remove 600 calories of heat every second. So from here, how much? 600 calories has to be removed every second. Okay. So the power required. So power is the work done. So this is the work done by electricity. Okay. So we have to find the power of the electricity. So here what we have to do is simply in 1 second. Okay, we are calculating for 1 second. In 1 second, the heat, Q2 is going to be 600 calories. So therefore we have Q2 upon W is equal to T2 divided by T1 minus T2. So what is Q2? Q2 is 600 divided by W, the work, work done by the electric power supply. T2 is 277 divided by 303 minus 277, which is equal to 27. So T1 minus T2 is 303 minus 277, which is 27, like this. So therefore the work done is going to be 600 into 27 divided by 277. So this is the work done in 1 second. Okay, now everything is going to be in calories. Okay, so since we have to calculate in watts, because it's mentioned in watt is in joule per second, so therefore we have to multiply by 4.2. okay, so this much is the amount of energy which is required to be given by the electricity in 1 second. So therefore the power is also going to be this only, because power is going to be W by T. T is 1 second. So now we calculate this. Now let us do some approximation. So you see 277 into 2 is going to be equal to 554. Okay, so we are just keeping it as 2 only, of course 2.2 something will be there. So 27 into 2 is again going to be 54, and 54 into 4 is going to be 200. So it's going to be close to this. So therefore the answer is going to be C. Since the options are differing in terms of multiple of 10, so that's why we took an approximation of 2 and then we did it. Okay, so that's why the power is